In this section, we're going to take a look at design business continuity, which is going to cover design a solution for backup and recovery and design for high availability. So it's a relatively small section, only 10 to 15% of the exam, but make sure you focus on the hot areas. It's all about site recovery. So some of the topics we've covered in some of the other sessions about Azure Site Recovery, backup, SLAs are a good thing, data retention, and also the high availability. So some of this is a repeat, but there are a couple new slides worth covering and noting. Azure Recovery Services contributes to a BCDR strategy. So site recovery helps to ensure business continuity by keeping business apps and workloads running during outages. Site recovery replicates workloads running on physical and virtual machines from a primary site to a secondary location. When an outage occurs at your primary site, you fail over to a secondary location and access apps from there. After the primary location is running again, you can fail back to it. Backup service. The Azure Backup service provides simple, secure, and cost-effective solutions to back up your data and recover it from the Microsoft Azure cloud. The Site Recovery Deployment Planner provides a report that has complete information about compatible and incompatible VMs, disks per VM, and data churn per disk. The tool also summarizes network bandwidth requirements to meet target RPO and the Azure infrastructure that's required for successful replication and test failover. Failover and failback in site recovery has 4 stages. Stage 1, failover from on-premises. After setting up replication to Azure from on-premises machines, when the on-premises site goes down, you can fail those machines over to Azure. After failover, Azure VMs are created from replicated data. Step 2, reprotect Azure VMs. In Azure, you can reprotect the Azure VMs so that they start replicating back to the on-premises site. The on-premises VM, if available, is turned off during reprotection to help ensure data consistency. Stage 3, failover from Azure. When your on-premises site is running as normal again, you run another failover, this time to fail back Azure VMs to an on-premises site. You can then fail back to the original location from which you failed over or to an alternate location. Stage 4, reprotect on-premises machines. After failing back, again enable replication of the on-premises machines to Azure. After you use Site Recovery Deployment Planner to calculate the bandwidth you need for replication, which is the initial replication and then the delta, you have a couple of options for controlling the amount of bandwidth that's used for replication. 1, throttle the bandwidth. VMware traffic that replicates to Azure goes through a specific process server. You can throttle bandwidth on the machines that are running as process servers. Influence bandwidth. You can influence the bandwidth that's used for replication by using a couple different registry keys. One is the upload threads per VM, and the other one is the download threads per VM. Located in the HKey local machine, software, Microsoft Windows, Azure Backup, replication registry key. There are scenarios in which you'd want to move your existing Azure IaaS virtual machines from one region to another. For example, you want to improve reliability and availability of your existing VMs to improve manageability or move for governance reasons. For this exam, it would be worth reviewing the prerequisite section on the different regions link on this slide. Use Azure Backup Center for Azure Backup Management. Backup Center is a single unified management experience in Azure. It enables enterprises to govern, monitor, operate, and analyze backups at scale. With this solution, you can perform most of the key backup management operations without being limited to the scope of an individual vault. Azure Storage offers different access tiers which allow you to store blob object data in the most cost-effective manner. The available access tiers include Hot, Cool, and Archive. We've talked about these before, but just a couple quick points. The Cool has to be stored for at least 30 days, and Archive have to be for 180 days, otherwise there can be a penalty. To help organizations comply with national, regional, and industry-specific requirements governing the collection and use of individuals' data, Microsoft Azure and Azure Storage offer a comprehensive set of certifications and attestations. You can find many offerings on the Azure Storage on the compliance link to ensure that Azure services are regulated in Azure Storage Service. They are applicable to the following Azure Storage offerings: blobs, files, queues, tables, disks, cool storage, and premium storage. Azure Storage always stores multiple copies of data, so it's protected from planned or unplanned events, including transient hardware failures, network or power outages, and massive natural disasters. Redundancy ensures that your storage account meets the service level agreements or SLA for Azure Storage, even in the face of failures. SLAs for storage accounts vary on the tiers. Review the SLA link to compare and make note of what the options are. But note the references in the next slide are even more specific per each specific storage redundancy option. So this is another one of those great summary charts that may be useful in preparing for the exam. This gets into the various SLAs, the different parameters, and the different storage types accounts. I'm not going to read through them all, but you can pause on this, and there are other links in this exam as well as the other review sessions we've done. When deciding which redundancy option is best for your scenario, consider the trade-offs between lower cost and high availability and durability. The factors that help determine which redundancy option you choose should include how your data is replicated in the primary region, whether your data is replicated to a second region that's geographically distant to the primary region to protect against regional disasters, whether your application requires read access to the replicated data in the secondary region if the primary region becomes unavailable for any reason. Azure Storage offers a geo-redundant option to ensure high availability even in the event of a regional outage. Storage accounts configured for geo-redundant replication are synchronously replicated in the primary region and then asynchronously replicated to a secondary region that's hundreds of miles away. Azure Storage offers two options for geo-redundant replication. The only difference between these two options is how data is replicated in the primary region. For geo-zone redundant storage, or GZRS, data is replicated synchronously across 3 Azure availability zones in the primary region using zone redundant storage, or ZRS, then replicated synchronously to the secondary region. For read access to data in the secondary region, enable read access geo-zone redundant storage, or RA-GZRS. Microsoft recommends using the GZRS or RA-GZRS for scenarios that require maximum availability and durability. Geo-redundant storage, or GRS, data is replicated synchronously 3 times in primary regions using locally redundant storage, or LRS, then replicated asynchronously to the secondary region. For read access to data in the secondary region, enable read access geo-redundant storage, or RA-GRS. This is another good eye chart, but we've covered some of these things. But designing for high availability, what are the options that we have for application delivery? So we've covered topics like front door, load balancers, not so much, but they are in some of the older slides that we have in this review session as well as others. Application gateways, traffic manager, we haven't really talked about that because that's kind of an older thing that we've covered many times. But if you're not familiar with traffic manager, you should be. It's essentially DNS redirects. Think about it like geographic dispersed DNS. So if we have a website in multiple places, you can have a central traffic manager point that can do a primary, secondary, or based on availability, things like that. But from a design perspective, which is what this exam focuses on, you want to look at your global options, your regional options, and your internal options, leveraging things like load balancers, application gateways, front doors. Another one that might be another thing for looking at designing business continuity strategy are the disaster recovery strategy for individual workloads, whether we're looking at one region versus disaster recovery across multiple regions, or backup, which is asynchronously replicated. We cover these in the last couple slides, but this is, again, a good visual graphic to help you to understand that. And that concludes Design Business Continuity.